Okay, let's go ahead and work over the homework systems, solving systems by graphing. In this homework exercise, we're given two equations, and we're trying to find out what solution solves both of them at the same time. So let's look at this first one. We have y-intercept. Remember, we're going for y equals slope times x. Okay, so the number right before the x is our slope, plus our y-intercept. Okay, now that can also be a minus y-intercept. Okay, so with that in mind, that 3 is the last number. It's in the spot of the y-intercept. So I'm going to go up to a positive 3 and put a point. With that, I know my rise over run. So I'm going to rise 4. The problem is I can't go up 4. When that happens, you can change both of them to negative. So I'm going to go down 4, 1, 2, 3, 4, and negative 3, 1, 2, 3. And that gives me a point here. Now I can't graph any more points there, so I'm going to move on. And by graphing more points, I mean solutions. So we have negative 2 is our next one. And up 4, 1, 2, 3, 4 over 1, 2, 3. And if we were to graph these real careful, we would see that they are in fact parallel lines that will never come together. And we can also see that by the slope being the same and the y-intercept being different. So in this case, there are no solutions. Okay, so that's your answer for number 1. When they're parallel lines, there's no solutions. Number 2, let's graph this one. Our y-intercept is 1, and then we're going negative 3 and positive 2, so negative 1, 2, 3, positive 2. We'll put a point there, 1, 2, 3, 1, 2, and I plot as many points as I can on the first one, 1, 2, 3, 1, 2, so that I know where the whole numbers are for that equation. Okay, now once we have that plotted, then we continue on and we do the next one. Y equals x minus 4. So here's our y-intercept, negative 4, and we're going 1 over 1x. So up 1 over 1, up 1, and we just landed right there on that other point. So that is the answer. That is the solution. And we see that it is x equals 2, so x is 2, and y is negative 2. And that's how you put the answer. Don't forget to graph the actual line though. If you don't graph the line, then you didn't finish, because the line is part of, it's what you're graphing. And the solution is where those two lines come together. That's the solution that satisfies both of them. Okay, number 3. Let's graph that first one. We have positive 2, so we're going to go up 2 and put a mark. And then we have 1x, or 1 over 1x. So we're going to go up 1 over 1, up 1 over 1, and so on. Okay, now like I said, I graph as many of those points as I can so that I know where the whole numbers are. Okay, next one, our y-intercept is negative 2. And then we're going up 1, negative 3, or down 1, positive 3. So down 1, positive 3, down 1, no more there. So up 1, negative 3, 1, 2, 3. And we landed right on that point right there. And that's the answer for both of them, because it's a point on both lines. So the answer is x is negative 3 and y is negative 1. And then don't forget to draw the two lines. Okay. Number 4. Our first y-intercept is positive 4. So we're going to go up, put a spot on 4. And then it's up 5 over 3, but we can't go up 5. So we're going to change both of those to negative. And that works as long as you always change them both. So now we're going to go down 5. 1, 2, 3, 4, 5. 1, 2, 3, and put a point. Okay, there's our first line. We could go 1, 2, 3, 4. Nope, we can't plot any more points. So now we're going on to the next y-intercept. And that's down here at 3, negative 3, excuse me. And we're going negative 2, 3. So down 1, 2, 1, 2, 3. Up 2 over 1, 2, 3. And then I land right on that other point. Okay, so that's the answer. So my answer here is also negative 3, comma, negative 1. Because we go over, so our x is negative 3 and our y is negative 1. All right, the next one. Y-intercept, negative 4. So I'm going to put a point on negative 4. And then it's negative 1 over 1. So down 1 over 1, or positive 1, negative 1. Doesn't matter where the negative is, as long as it's only on one of the two numbers. Okay, so now we have our line there. Our next one is positive 1 is our y-intercept right here. And then we have a positive 3 and positive 2. So up 3, 1, 2, 3 over 2. That didn't land on a point I already had drawn, so I got to keep going. I can't go up, so I'm going to go down. 3, 1, 2, 3, and left 2. And here we have it right here. It landed on that point. So as long as we change them both to negative, we're okay. So we landed right here. So our answer is when x is negative 2, y is negative 2. Okay, and then we draw the lines. And we see that that's where they actually cross. And that's what we're doing. That's what we're looking for. We're trying to find out where the two lines cross. Okay. Now, we have this next one. We cross at negative 3. Goes up 1 over 1, 2, 3. Down 1, left 1, 2, 3. That's as many of those points as I can plot. So now let's go to this next one. Y-intercept is at 4. And we have a rise of 8 over 3, but I can't go up 8, so I'm going to change both of those to negative and go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3. And I land right on that same point. So that's my answer. And I say, okay, x is negative 3. And y is way down here at negative 4. See my x value and my y value. Okay. And then I draw the two lines. And then I'm done. Now these ones, 7 through 10. These ones are a little different in the fact that they're inequalities. Okay, so let's go ahead and go through how we do these. We graph them the same way at first. So we have a y-intercept of negative 2, and then negative 1/3. So negative 1, 1, 2, 3. Can't do that anymore. Now I'm going to draw the line. Is it a solid line or dashed line? It's got that little line underneath the inequality. So that tells me it's a solid line because it's equal to, not just less than. Okay. Next one, positive 3 is my y-intercept. And then I have a negative 2 over 1. So down 2, 1, 2 over 1, 1, 2 over 1, and so on. And that also is a solid line because it's less than or equal to. It's got that line right there. So we're going to draw that line. Okay. Now our question is where do we shade now? Okay. The first one, y has to be less than this line right here. So we picture all this stuff that we just did as just the line. Okay, so that's all that box is the line. Okay, y has to be smaller than that line. That means everything below that line is the answer. Y has to be everything lower than that line. Well, over here, we have a second line, and y also has to be smaller than all of that line. So we look for where y is smaller, and we see, hey, okay, the answer has to be correct for both of them at the same time, not just one or the other. This one is only correct for the blue, but none of the other colors. This one over here, this section, is correct for the green, but not the blue. You're trying to find out where they're correct for both of them. And that's right here. Where they overlap is where they work for both of them. So that is where I shade in, where it works for both of them, where the two colors overlap. Okay. Number 8. We have a positive 1. So we go down 2 over 1, because that's negative 2 over 1 slope. So down 2 over 1, down 2 over 1, and that is a dashed line. It is not a solid line. We know that because it does not have the line underneath the inequality. So with that in mind, we're going to go ahead and draw our dashed line. And once we have that drawn in, then we can graph the other line. We see our y-intercept, again, is at negative 2. So with the y-intercept at negative 2, we have a 1x, so that turns into 1 over 1, so our slope is up 1 over 1, and so on. And that also is a dashed line because it's just less than, but not equal to. So we have two dashed lines. Now we got to figure out what's shaded. This first one, we have our line, and we say, hey, y is bigger than that line. So that means everything above that line is the answer, because the y value has to be greater than 1. We see our y value here is 1, 2 is bigger, 3 is bigger, 4 is bigger, so everything bigger than that. Okay, with the same thought, this next one, y has to be smaller than that line. So that means right now y is negative 2. It has to be everything less than negative 2. Okay, so that leaves us with both of those lines, and we need to find an answer that fits both of the inequalities at the same time. And to get that, you find right here the two colors overlap. So that's the part that we're going to shade in. Right there. And that's the answer for number 8. Number 9. These last two I'm going to do without the color transparencies. Number 9. We're missing a y here. There's no y, which means it does not cross the y-axis. It means x is greater than 3 or equal to. Where it's or equal to, it's everything right there. That line, vertical line that doesn't cross the y because the y is missing. Next one. Y-intercept is negative 1. Then it goes down 1 over 3, so down 1 over 1, 2, 3, and so on. Okay, and that is a dashed line. Okay, we know it's dashed because there's no line underneath the inequality like there is up there. Okay, now we got to figure out what to shade. X needs to be bigger than 3. Which number is bigger than 3, 2 or 4? 4 is bigger than 3. I draw an arrow and say, okay, that needs to be shaded that direction. Okay, now the next one, y is greater than the line. So y is bigger than the line that we drew. So y is bigger. Well, what's bigger than negative 1? Everything up here. So that means I'm shading up for that one. Now, if we were to shade those arrows, you'll notice that it's going to overlap right here. So that's the part that we shade in. And then we leave the rest of it alone. Because this answer works for that vertical line, but not the other equation. We need an answer that works for both of them. And number 10. Our y-intercept is positive 3. Then we go negative 2 over 3. And we see that that is going to be a dashed line. So we're just going to go ahead and do a dashed line. The next one is negative 1. And it goes positive 2 and over 3. And that is a solid line. Now we have those two graphed. Let's go back to the first one. I need to shade everything below that line. So y has to be smaller than the line. So I'm going to shade down. Now this one, y has to be bigger than that line. So everything on that line, y has to be bigger. And if we look, the two arrows are coming together right here. Over here, they're pointing apart, but right here, they're going to cross. So that's the part that we shade in, right there. So that's how you do the homework on systems of graphing, or systems by graphing. I hope that helps.